Hello everyone. Today we study in the chapter 8. In this chapter, we talk about the uh, microcontroller technology, Interlab, DMA, and program IO. Here, this is the top objective of this study. After you are learning, you can known about the current tense of the microcontroller and IoT device, and also you can explain the IO interrupts. The IO interrupt is a technique for change the program to service the signal from the input, just as a keyboard. That is technique to improve the speed of the computer. And finally, you will understand the function of the word DMA, that is a direct memory access, and the interrupt. You will know the difference between the DMA and interrupts. Here we have 5 topics for study. First, we talk about the microcontroller current technology, and then the second, that is a data transferring control, data transfer to controlling in the computer system. And the third, that is a program IO. That I think it is important for you to understand the difference between the program IO, interrupt, and DMA. Here we will talk about the microcontroller from the past to the present. The microcontroller can divide it in 3 eras. By the first, that is the first generation of the microcontroller. Inside the microcontroller have already is have already IO port, time, and interrupts. IO port, timer, and interrupt, and also is having already the EEPROM, that is the memory like as a lump by you can read and write, and data can correct without maintaining without the supplying from the battery. Here, this is the microcontroller in the first generation have only IO port, timer to generate a signal, for time interrupt to control the time and duration, to turn on turn off the light in the IO port, and control anything. You can program the time and also getting input with the interrupt. After we learning in this slide, I will talk about the interrupt. What is the interrupt? I will explain to you. And the second, that is the microcontroller improved by add the function about the ADC, ADC operation from the analog to digital converter. And also is have the function about the PWM, power width modulation. And what is the ADC? The ADC is here, ADC. When you send a signal, just add a signal from the sensor. I give an example about the microphone. The microphone signal is analog sine wave signal. The analog sine wave signal sent is to a device that we call ADC, that is analog to digital converter. The ADC module installed in the many devices, such as a mobile phone. In the mobile phone, when you speak on the mobile phone to the microphone sends the analog signal to the ADC to change to digital data, and then the digital data encoding and transmits to the cell site. Yeah, this is a ADC work. And the second, that is the power width modulation. That's relate about the width of the power. And here in this picture, look at this. We have the 1, 2, 3, 4, 5 power signal. I zoom the picture. 5 power signal. By in this, This is a no pulse signal. We call this is 0% duty cycle. And here in the cycle, we have only a small two or 5 volt pulse, about the 25% duty cycle. That means this is on during from this to this is 100 and on during 25%. And 50% duty cycle, that means this is turn on, this is half, and turn off is half cycle in a cycle of the signal in a power signal. And 25% duty cycle, that is turn on the long time about 25% from the 100. And 100% that is turn on, not turn off. Here, why we need to use the power which modulation. Here in this figure, a motor, when you supply the battery to the motor can turn on and lowering the motor is work. But when you need to control the motor speed, some people reduce the voltage. From here, this is we supply only 1, 2, 3 battery. Maybe if we need to reduce the motor speed, we supply only 1 battery. But when you reduce the voltage to the motor speed, when you reduce the voltage, it is change speed. But the motor speed no torque. Torque is แรงบิดในภาษาไทย torque no torque. So when we use the motor speed in low speed and need to use the torque of the motor, so you need to supply the motor with the pulse signal. That means you turn on, turn off in very short time, send it to motor. The motor will have a torque that is running in low speed. In these techniques, we use that to control the motor. When you use the EV car to control the motor speed for driving the car, we use the technique of power with modulator. And moving back, here in this is a diagram in a microcontroller in the first generation that I mentioned it to you. Inside the microcontroller have a CPU. Here it is all of the block diagram. This is integrated inside the microcontroller. In the microcontroller chip have a CPU, Interlab controller, ROM is a memory, RAM, timer, have a timer 1 and timer 0, 2 timer to control turn on, turn off, and duration of a program. You can program the timer. When you need to program the timer to send a ticker every 1 second, you can program the timer to send the signal every 1 second. Serial port to control, to change the data from the serial to the parallel and communication to the CPU. I/O port to turn on, turn off the device. And the bus control, this is control some device, external device for reading, writing. And also finally, that is OSC, is oscillator clock. That means it is a system clock for the CPU. Example, in this CPU run at the 20 megahertz. So the oscillator will generate the signal at the 20 megahertz to supply the CPU. Okay, now the third the third generation of the microcontroller that is improved by integrated the wireless network that we know about the Wi-Fi, and also integrated about the Bluetooth. That means you can connect the wireless device to the microcontroller. Here in this picture, I show you this is we call in this chip we call ESP8266. ESP8266. That is we call the Arduino. This is ARM technology, and here in this is a antenna for Wi-Fi antenna, and some device not this that have a Bluetooth controller installed to the chip to the board. Here in this board have the ADC analog to digital converter, and also it have IO port. Here this is IO port GPIO, that is general program IO. GPIO, that's abbreviation from the general program IO. Voltage supply, ground, RX and TX. This is a serial communication. Here this is serial communication, and also it have a clocks, enable, and voltage. Here in this is a small. This is the same technology to ESP8266, but this is a very small size and limited by the number of the pins. It have only serial communication, and have only two IO port, IO0 and IO2. You can use in this device to control the turn on, turn off, the light, the lamp, and also the device by control maximum. I think it is a maximum 2 device or 4 device when you are decoded from this external this device to set the chip to decode the number, to decode and connect to the more device. Here we can conclude that the technology of the microcontroller from the first to the present, from the past to the present, that's changing by add the module to use to control, such as it have a IO port, timer, memory, and analog to digital. That means you can send the analog signal to convert to control the device, and also send the power width modulation out to control the motor. And you can control all of the device by using the wireless techniques. That's the long distance by using the Wi-Fi, and the short distance by using the Bluetooth. Okay, now when you use the computer, we need the device such as the mouse, sound and video, sound card and video card, and printer, scanner. From the device can divided in three kinds. By the first, the device that sends is very small data size, medium data size, and large data size. Printer and scanner, when you scan and printing the paper, printing the document to paper, the data that is a large data for sending from the computer to the printer, because this is related to the pixel on the paper, pixel or dot on the paper. If you printing in the DPI dot per inch at the over 600 dpi, that is a need to use the very large data sending from the computer to the printer. But the response time, when we talk about the response time from the device and response time for communication between the mouse to the computer, sound card to computer, and printer to computer. That is the difference. By the mouse, the response time needs to respond in real time. We love to use the mouse when you move the mouse up or down and respond in the real time. We no need to lag for moving when you move the mouse. And also sound and video. When you're watching the video, you love to watch the video in the data transform in real time, not pause in and reload the data. So data transfer streaming, that is streaming data in the real time. But when you're printing or scanning the data, the paper to the computer, you can wait a few minutes, a few seconds for sending the data. So the response time, that is non-real time. This is non-real time. So when you compare the data size and response time, can divide it in three kinds. Okay, now when do you ever find the computer freeze during copy a large data? Maybe sometime when you copy, example in here, I copy a large data, 3.24 gigabytes to external device, I have a problem during I copy. The computer send the message not respond. I think you have experience to meet in this problem. In this problem occur by the one or two or many reasons. By the main reason, that is a hardware error or disk error. Hardware error or disk error, such as when you use the hard drive, maybe your hard drive have a fraction, have a small error in this. Small errors in this that we call bad sector in your hard drive. That's when the head of the hard drive move to the bad sector section. The hard drive will stop or waiting and lead at the location again. So the hardware will stop at a few minutes. That is generate the hardware error signal. And sometimes the device you not turn on the DMA function. What is DMA? I will explain after this slide. You don't turn on the DMA function or interrupt management. Here in this reason occur when you use very old operating system. Example, you use in operating system in Windows 95 or I think Windows 95. Before Windows 95, user can control turn on turn off the DMA and interrupt. But today all of the computer, this is a turn on always turn on DMA and interrupt management. So here in this the second problem that is not occur in your device. Now I will show you and explain the words DMA and interrupt. From the mention before in here in this slide, I think you don't understand the words DMA and interrupt. The DMA and interrupt is important for transferring data and communication between the computer and I/O device and external device. So here, the transfer the data and communication between the computer to device can divided into three techniques. The first we call the program I/O. The second that is interrupt I/O, and the third that we call the DMA, that is direct memory access. Now we will talk about the program I/O. The program I/O, that is this programmer organize the process of reading or transferring the data. The programmer organize the techniques for reading or transferring data from the computer to the device. That means organized by programmer write the commands or coding to control process of data transferring and communication between devices. The system performance is depend by the programmer experience because the programmer when some programmer have a high experience for writing the computer code, they can organize the time of reading or writing the data. Here in this, I will explain to you in this. Look at this picture. In this picture, that is home security system. Home security system, that we know the CCTV, but the home security system not only the CCTV, it have about the sensor at the door and window. That is key switch sensor. When someone open the window or door, can send a signal to the home security system, and also control the temperature or fire sensor, and also motion detector, and controlled by the main keyboard, main key. This is communication. Here in this overall system, we call the home security. When you develop a computer to make a project home security, you look at this. We have a lot of device: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 device. For this example, we have 10 device to communication in the system. When you write the program by use the program I/O, that means the programmer needs to write a program to control reading and sending the data from the 10 device. That means the programmer will write the code a few minutes for reading here in this switch, and then check the temperature or gas sensor, and then check the CCTV, and check the motion sensor by the code write by the sequential เป็นตามลำดับนะ sequential from first and then second, third, fourth until to 10 device by the sequential. And the programmer organize the sequence for reading the data. When some device have a problem, example, an infrared motion sensor have a problem, and in this device generate the error by send a lot of data to the computer. During the program run to here, the program may be stop running by stop to in this process, not move to next process, because it stick to check or communication in this device. So I told you that is the problem when you control the sending the data with the program I/O by the first uh, the first disadvantage, that is the hard to control the sequence of the reading. And the second, that is when a device have a problem, your program cannot script or cut it out from the main process main process, because all of the program controlled by the programmer to control the sequence. Here, moving back, a system with a lot of device. Example, in a car park, system, a car park have maybe more than 100 car on the car parks. That means 100 device connect to the system, to the system. That is difficult to write the code to control a lot of device. Example that I show you, home security system. Here I will explain why this is important for program IO that is difficult for writing the code. Here in this is the sequence of check the device in home security. The sequence start by the program check is the data ready from the sensor. When the data not ready, is moving back to check and waiting again until the sensor ready to send the data is moved to process, read data and store data. Mean this is have a loop for check the data ready. Check the data ready. That means the CPU wait a loop not an efficient for the CPU because the CPU have the useless time for waiting the data. So here this is a disadvantage of the program IO by the CPU waiting for reading the data of the device. And here this is activity 8.1. I think we will do in this activity after COVID. And on the side we will doing this activity. Okay, the third I told you about the program IO, about the Interlab IO. I will explain the Interlab. From the problem of the program IO, that is a lot of device. It's difficult for programmer to write the code. That is the main problem. And the Interlab help to programmer for writing the code easier. By in this, the interlab is mean breaking a process to switch to do service interlab. Service interlab is a program, a small program for service this interlab. After doing the service complete, it's moving back to run the remaining code before breaking. For this example, I show you when you playing the computer games, your mother told you to lift the box. That is the interrupt signal from the mother to tell you for lifting the box to help her to lift the box. That is like as the interrupt. That means you doing like as your CPU playing the game and the sensor send the signal to you to lift the box. Here you switch stop by playing the game and services by lift the box. Here in this picture, the program run here in this is main program. During run to this, it have a interrupt signal from the external device sent to the CPU. The CPU switch from this works to service the interrupt. After that, when doing the interrupt complete, it's moving back to the main program to run the remaining code. Yeah, this is the interrupt. I show you the interrupt pin. Here, where is the interrupt? This is interrupt control. Interrupt signal. This have two interrupt signal. And in this picture is don't have interrupt. You can write the interrupt by assign to any pin in the computer in the microcontroller. Okay. Inside the interrupt, your computer have all of the computer and also the on your mobile phone is have the interrupt. By the interrupt divided in four categories. The first interrupt we call program interrupts, and the second timer interrupt, hardware failure interrupt, and I/O interrupts. Now the program interrupt. The program interrupt is an interrupt from the program when you are run in this example. I run in this computer. My computer open a lot of program. Example on this. Yeah. Example, I open the Safari. I open Safari. The program will switch from the Chrome to the Safari. And when I open this program example, I open calculator. Now my computer have three programs: the Chrome, Safari, and calculator. The program will switch, CPU will switch the service from the Chrome to Safari to calculator, switch by sequence like this. So here we call this is a program interrupt. Interrupt by the program, and also the second that is a timer interrupt. This is interrupt by time. You can set the timer ticker. Example, I set the ticker every 100 millisecond. Every 100 millisecond. Your computer by the timer interrupt device will send the ticker signal to your computer. You can use the ticker to switch the program. You can use this ticker to do any service in your computer. And the third, that is the hardware failure interrupts. The hardware failure, that is hardware error interrupt. Example, interrupt from the example here in this. When you copy a data from your computer with a USB device, USB thumb drive, during your copy, you remove the USB device out. That is generate the hardware error. The hardware error is a very high error for sending to system. Here, this hardware error will send to the operating system to know this hardware is error. And also, hardware error is generated by the hardware such as the communication module. When you connect to the internet and internet down and internet not connects, Wi-Fi is outside area, this is hardware error will send to the CPU. That is we call the interrupt by the hardware error. And the I/O interrupt. The I/O interrupt is interrupt from the device by input-output device. Example, I paste my keyboard. When I paste to the keyboard, the signal from the keyboard that is input switch sent to your computer. That is the interrupt signal to your computer. That is some students not understand difference between the I/O interrupt and program interrupt. The program interrupt by software. Interrupt by software. Example, I have three program and a program I send running by background running. Background running. Example, I send it to rendering the video and convert something. The interrupt from the program that is signal from a program to the CPU to know this is interrupt. Example, I I watch the I browse the internet and my friend send some send some message to the Line application. The message show alert to me on my system. That is the program interrupt. And also the program interrupt used when you open a lot of the device, a lot of the application. When you open three application, example here, I open three application. The program interrupt will send the interrupt service to the device by relate to the timer interrupt, because when you switch from this to this to this, you need to use the timer to control the timer switch to for interrupt in all of the device. Okay, now we will doing in this activity in activity 8.1 divided by 0. Divided by 0 is generate an error to your system. When you divide by 0, the calculator cannot calculate. Example here, I show the calculator. I type 5 divided by 0 is not a number, it's error. So here, this is the error by very important for programmer develop the program, because some program will after generate the divided by 0, it will stop running the code. Example, I will show you in a short minute, and I think you need to open the browser and type online GPU, online GDB, sorry. After that, after you get the online GDB, you need to write the code here to online the GDB. Here in this, I write this code complete, and before I running this code, I will explain to you in the course. In this course, K minus T, K subtraction by subtraction 3, that is have a 0 here in this 0, that is divided by 0. Now I will comment in this line and then I run this program. Before I running, I click here to see language and click start. The program show hello world, and after that I remove comment and I click start. Program not show hello world. Program not show hello because this is occur the divided by 0. That means when you have a lot of code below this, and your code found the divided by 0, your program will stop or terminate from the memory, not running the code below. So here this is important for you for about the divided by 0. And also the divided by 0, that is the cause of the hardware failure interrupt or hardware error interrupt. Sorry. Okay, I think you understand about the concept of the divided by 0 concept about the interrupt, and also Sorry, my computer have about the um my mouse. My mouse have about a problem. Okay, now I think you understand about the concept of the interlab. The interlab have four kinds program in timer, hardware, and I/O. Now the activity 8.2 and the activity 8.2. Here in this activity, I I will show you in the next week. In next week by simulation on the Tinkercad. Tinkercad. I just found the Tinkercad. You can write the code to control the LED to control by simulation. By simulation, it is beautiful for writing the code and easy to understand. Here, this is example code. If you have a time and you no need to wait for next week, you can open the Tinkercad, and also here it is Tinkercad. You join is now and log into Tinkercad. You can develop the device by simulation. By simulation. Yeah. Now I create a lot of device to simulation here in this and click this to paste the device and to make a control to write the code, do anything. And if you no need don't have to wait for next week, you can look my video for the second for the subject ICS. I have a laboratory to to make to make a simulation on the Tinkercad. Okay. Here I explain to you again interlap form timer. The interlap form timer that is program switch to do something by the timer setting. Example, the single process run as 10 a single processor. So sorry, single processor that runs 10 programs in the same time. It must to switch to each program by setting 1 divided by 10 timer switching. That's here. This is timer for switch for running the program by the to service the 10 program running. And also here in this example, when you remove the USB device, it will generate the error by hardware error. Hardware failure error occur by writing data to USB error. During writing the data, user immediately remove USB device. And also network connection loss, bad sector in the hard drive. Yeah, and interrupt IO. Interrupt IO is interrupt signal from the user when you move a mouse or and paste the keyboard. And also the interrupt IO can generate by the some device. Example, analog to digital device and sensor in your computer that is can generate the IO interrupt. Okay, now the last subject, the last topic for this line, I will talk about the type of the interrupt. The type of the interrupt divided into types. That is the sequential interrupt. Sequential interrupt. The sequential interrupt when you're running the main program and you move the mouse the program will switch from the main program to run service in the mouse. switch for the mouse. This is code for mouse. And after that is moving back to the program, and the certainly is will switch to service the keyboard, because this is a sequential interlab, because mouse and keyboard have the same priority. Now we have the new keyword priority levels. That means the interlab have the priority of the interlab. The device such as mouse and keyboard are the device in the high priority. So when your user move a mouse or press the keyboard, the service will service in quickly and service simultaneously. In some device that is very low or low priority, example printer, you can wait a few minutes during printing, a few seconds during printing. So here in this main program run here and have doing a service about the interrupt for printing. During running the printing to communicate to printer, you move your mouse, the program will switch from the service in the printer to service the mouse. So here in this we call next interrupt, because the interrupt from the user and interrupt to the low priority. Here in this is very low priority. And the mouse have a high priority. The program will switch from the low priority to service the high priority first. We call this is next interrupt. Interrupt have sequential interrupt and next interrupt. And the last one, in this we don't call the interrupt, but that is the DMA techniques. DMA, this is operation from the direct memory access. Direct memory access is the technique that allow the IO to send and receive the data, directly from the memory to the device without controlled by the CPU. Very old computer system, that is the process like this. By the IO, when the IO need to save the data to memory, it is organized by the CPU. The CPU organizes the location on the memory for IO writing the data. But now, the new computer and also the mobile phone and new device that have a DMA or of the new device, the CPU send some command to DMA to start the DMA works. The DMA will, after that, the DMA will control the transfer the data to write the memory directly without controlled by the CPU. By the first time CPU send a command to DMA, and then DMA send a large of data, amount of the data from the IO to write the memory. CPU can have a free time for service in the high priority for here. So when a new system have the DMA technique, CPU have a free time. When we compare with the no DMA, the no DMA CPU don't have the free time. And here after CPU have the free time, CPU can switch to do some work about the calculation or doing anything in the system. Yeah, this is the advantage of the using the DMA. Now we after study, I think you have you know about the current tense of the microcontroller And also you can explain the IO interrupts, DMA, and this is related to about the speed of the computing in the computer. Okay, I think in this chapter is you complete to know the subject here on this, the topic here on this, and this is see you next week and bye bye.